Hello, everyone, and welcome. Have you ever looked up at that beautiful moon in the night sky and just wondered, what's it all about? Well, today we're going on a little journey. We're going to find out why it shines so brightly, what it's really like up there, and we'll even dive into what happens when it plays a cosmic game of hide-and-seek with the sun. So let's get started. So let's kick things off with a big one. It's probably the first question everyone has. We see the moon glowing up there, sometimes so bright it lights up the whole night. But why? Where does all that light come from?
Okay, get ready for a surprise. It doesn't. The moon doesn't make any light of its own, not a single bit. You can think of it more like a gigantic, dusty mirror hanging in space.
So here's the secret. All that beautiful moonlight you see, it's actually just borrowed sunlight. The sun's light travels all the way to the moon, bounces off its rocky, dusty surface, and then reflects right back down to us here on Earth. And the only reason it looks so big and bright is because it's our closest neighbor in space, way, way closer than the sun.
All right, now that we know why we can see the moon, let's actually go there. Imagine we're hopping into a rocket and blasting off. It's time to take a much closer look at what it's like to actually stand on the lunar surface. Our destination? The moon itself. So, if you were to step out of your spaceship, what would you see? Well, it's a pretty wild place. The ground is all rough and uneven. There are these huge round pits called craters everywhere, left behind by crashing asteroids. You'd also see towering, steep mountains and massive flat plains. But here's the most important thing. There's absolutely zero air to breathe and not a single drop of water to drink. And that lack of air, that lack of an atmosphere, is a really big deal. It's exactly why no life as we know it could ever survive there. There's nothing to breathe, and there's no protective layer to block the sun's powerful and dangerous rays. That's why astronauts have to wear those big, bulky spacesuits. It's a totally different world from our own. But wait, there's something else that's completely different from Earth, and it's something you'd feel right away: gravity. The force that holds you to the ground on the moon is only 1/6 as strong as it is here. And trust me, that changes everything. So what would that actually feel like? Well, you'd basically have superpowers. You could pick up things that are 6 times heavier than what you can lift on Earth. And the best part? You could jump and leap so high, taking these long floating steps. It would feel almost like you're flying. How cool is that? Okay, let's fly back to Earth for a minute. Even though the moon is thousands and thousands of kilometers away, it has this incredible, powerful influence on our planet. It literally controls our oceans. This amazing power is all thanks to gravity. The moon's gravity is constantly pulling on our entire planet. But since the water in our oceans is a liquid, it gets pulled much more easily. This constant tugging is what causes the sea level to rise in different parts of the world, creating what we call a high tide. This picture shows it perfectly. See how the moon's gravity pulls the water towards it? That creates a bulge or a high tide. But here's the really cool part. Another high tide forms on the exact opposite side of the Earth. It's almost like the water is being stretched out. And the areas in between those two bulges, well, that's where you get low tide. This whole cycle repeats about every 12 hours, which is why most beaches have 2 high tides and 2 low tides every day. And now for the most spectacular show in our skies. Every once in a while, the sun, the Earth, and the moon line up in a perfect straight line. When they do this, they cast giant shadows on each other, creating an amazing event that we call an eclipse. So, what is an eclipse really? In simple terms, it's just when one thing in space blocks the view of another. It's all about one object passing into the shadow of another one. It's a cosmic alignment, a game of shadows on a massive scale. There are 2 main kinds, and the difference is all about who's in the middle. For a solar eclipse, the moon is in the middle. The lineup is sun, moon, earth. But for a lunar eclipse, the earth gets in the way, so the lineup is sun, earth, moon. It all comes down to who is casting the shadow. Let's take a closer look at a solar eclipse. This is when the moon passes right between the sun and us. Now, it's an incredible coincidence of nature that even though the moon is so much smaller than the sun, it's at the perfect distance to block it out completely. When this happens, the moon's shadow falls on a small part of the Earth, and for a few minutes, day turns into a strange and beautiful twilight. Now, let's flip it around for a lunar eclipse. This time, our own planet, Earth, moves between the sun and the moon. So we cast a giant shadow out into space, and the full moon passes right through it.
This can only happen when the moon is full, and as it gets covered by Earth's shadow, it can get very dim, and sometimes even turn this amazing, deep, reddish color.
You know, the moon's steady, predictable path around the Earth has been a huge inspiration for us. It was our very first satellite, a natural one, and by studying it, we got the idea to build our very own. That's right, the moon is our one and only natural satellite. But we humans are pretty clever, right? We figured out how to build our own machines, launch them into space, and get them to orbit the Earth, doing all sorts of important jobs for us, just like the moon. And we call these man-made objects artificial satellites. You probably use them every single day without even realizing it. Whenever you use your phone for directions, check the weather, or watch TV from a different country, you're getting information that's been bounced off one of these incredible machines circling high above our heads. This whole new world really opened up back in 1957. That year marks the official start of the space age, when humanity launched its very first artificial satellites into orbit. And just like the moon, if you look very carefully on a clear night, you can sometimes spot them. They look like tiny, moving stars reflecting sunlight back down to us as they silently glide across the sky.
And my, how far we've come since then. From those first tiny satellites, we now have incredible space stations where astronauts can live and work for months on end. They're up there right now conducting experiments and pushing the boundaries of human knowledge as they explore our amazing universe.
So let's end with this thought. The moon was our very first companion in space, our natural satellite. It taught us about gravity, tides, and inspired us to reach for the stars. Now, with thousands of our own artificial satellites whizzing around the Earth and exploring the solar system, the big question is, what amazing things will we discover next? The journey is really just beginning. Thanks for joining me.